Welcome to video number 298. In this video, I am going to show how to find out growth rate of an economic variable. Economists are often interested in finding out the growth rate of certain economic variables, including population growth rate of GNP, money supply growth rate, employment growth rate of productivity, and trade deficit growth rate. Let us suppose we have a variable called y, and that is the personal consumption expenditure. Let us suppose we are interested in finding out the growth rate of personal consumption expenditure. Assume that yt denotes real personal consumption expenditure at time t, and y naught the initial value of the personal consumption expenditure. Now we may recall the following well-known compound interest rate formula from our introductory course books in economics, and the formula is given by yt equal to y naught into 1 plus r raised to the power t, where r is the compound interest rate over time of y, and if you take the natural log of this equation number 1, we get natural log of yt, which is equal to natural log of y naught plus t natural log of 1 plus r. If we let that beta 1 is equal to natural log of y naught and beta 2 is equal to natural log of 1 plus r, we can write equation number 2 as natural log of yt is equal to beta 1 plus beta 2 t. And if we add the error term to this equation 3, then we get equation 4, which is equal to natural log of yt equals beta 1 plus beta 2 t plus ut. This model is basically linear in parameters like any other variables, and in order to show the growth rate of the personal consumption expenditure, I would open my data in Stata, and here is the data. Let me clear first this data. So I would like to open my data from here, and I am interested in this data, that is formatting data, TS set, creating trend, and so on. So here is the data, and if I click on this, I have just only one variable, and that is personal consumption expenditure, and the data is measured in billions of dollars. And my aim is to find out the growth rate of personal consumption expenditure over this time period. So first of all, this is just data on one variable. I would like to express this data in a time series, and I will declare this data in time series, and then I will format the date. Finally, then I will show you the graph of time series line of the personal consumption expenditure, and I'll regress the log-lin model. So first of all, I'll go to my Stata, and here I will generate the date command. Since there is no date, so I will generate date, and I'll give the formula equals TQ. Since I am declaring this data in quarterly data, so I'll write TQ. So TQ is the short for time for quarterly time series data, and within parentheses, let us suppose I am interested in declaring this data as quarterly data from 1993 quarter 1. So I will write Q1 parenthesis closed, and then I will write +1 underscore n minus 1. So it will create a date variable. And if I browse this, so under this date, these figures starting from 132 to 154, these are not understandable. So what does this stand for? Because as a date, 132 means what? So this is a Stata readable, but this is not human readable. So I would like to format this date, and for that I'll write format date, and then I'll write the percent and with that q. So I'm going to format the date variable as quarterly data. So if I check the data, now the date variable must have been declared as a quarterly data. So let me see it in the browser. So yes, previously there was a 132 here. Now it has been converted into quarterly data. So this is first quarter 1993 Q1 up to 1998 Q3. So my data has been converted into time series data, and that data is quarterly. Now I will tell the Stata to declare my data as time series data. So I will use the command tsset, so time series set, and what I am setting, this date, this variable I am declaring as a time series set. So yes, the data has been converted. So this is time variable data, and this range is from 1993 Q1 to 1998 Q3. So change in time is just 1 quarter. So this is quarterly data. So after this, I would like to, since I'm going to measure the quarterly data, the growth rate of the personal consumption expenditure, and as I showed in my slide here, that finally I will be using this expenditure, this model. So my dependent variable will be natural log of YT. In this case, it will be natural log of personal consumption expenditure, and I'll regress this log of personal consumption expenditure on T. So let me go to my data. Since I'm here, so I have this data actual values. So I want to convert this into log. So I will generate another variable, and I'll define it as LPCE. So it means that will be log of personal consumption expenditure, and that should be equal to log and within parentheses PCE. So if I press enter, Stata has generated LPCE. Now this is in log form. I have converted PCE into log form. So let me browse it, and you can see the data. Now see, this is the actual values of personal consumption expenditure, and these are the log values, natural log values of personal consumption expenditure. So now I can run my regression, and I will give it the command reg lpce or t. But for that, first of all, I will have to create trend variable. So I'll write generate trend equal underscore n, and by this command generate trend equals underscore n, the Stata has generated another variable which is trend. So I can show it to you in this browse. So this is the trend variable. Okay, so it has created these values from 1 to 23. So it means these are 23 quarterly 23 quarter data. So let me close this, and now I will run a regression. So regression of this variable LPCE, that is natural log of PCE on trend, and if I press enter, here is my regression. So basically this beta coefficient shows relative change in the dependent variable divided by absolute change in the exponential variable, and that is a time variable. So this basically shows a percentage change in person consumption expenditure due to a unit change in time, that is 1 quarter. So this is how we explain that. So now if you look at this value, the value of the intercept is 8.35 and the value of the coefficient is 0.0080, and if you take the percent of this, it means that if there is 1 quarter change in time period, there is 0.81% change in the personal consumption expenditure. And let me also show you the graph of the time series. So it would be L trend, LPCE, it should be TS line, LPCE. So this graph shows the growth rate of personal consumption expenditure from quarter 1993, quarter 1 1993 up to 1998 quarter 3. This shows the growth rate of the personal consumption expenditure. So my dear students, this example illustrates the growth model, and it considers the data on personal consumption expenditure, in which I regress the natural log of personal consumption expenditure on trend variable, that is time, and I explained the various statistics of the regression, in which this is the ANOVA, regression sum of square, residual sum of square, total sum of square. This is the F statistic, this is probability value, and this is R squared value, which is 99%. This is adjusted R square. These are coefficients, these are standard errors, these are t values, and these are p values. So this is how we can measure growth rate in economic variable, and it is very simple, that we will take the log of the dependent variable and we will regress it on the time variable, that is the trend, and then we can also see the graph. As you saw it in this, there is upward trend in the personal consumption expenditure, and it basically shows, this graph basically shows the growth rate of personal consumption expenditure over time. I hope this was quite useful for you. If you have any question, you can note down your question in the comments, and I'll try my level best to come up with the answer. Thank you. See you in another video.